Hey guys, this is Peter Nelson, co-author of Flexibly Periodized Autoregulatory Systems, along with Joe Conley. As I've mentioned previously, as we progress through the editing process and get closer to an official release date, we're going to be putting out some promotional material. Things like videos on how we actually put the book together, and background information on topics that we'll be discussing in the book, guest features on various podcasts, guest posts on various blogs featuring sneak peeks of material from the book ahead of the actual release date, and more. So if you haven't done so already, we highly encourage you to check out our various social media accounts so that you don't miss any of the stuff that we'll be putting out in the coming weeks. The information on those accounts, the usernames and the handles, will be included in the description of this video, so be sure to check those out and give us a like or a follow so that you don't miss out on any of that stuff if you haven't done so already. Today's video is going to be sort of a piggyback off of my previous video in which I discussed the role of various types of evidence within the framework of an evidence-based model. And I'm going to focus in actually on scientific research specifically. As I alluded to in that video, reading and analyzing scientific research is really a skill. And in order to maximize the potential benefits and also avoid the potential pitfalls that can accompany utilizing scientific research to inform coaching and programming philosophies, it's really necessary to hone that skill and really learn to effectively and efficiently navigate a research paper. Now, there are certainly multiple ways that you can go about reading and analyzing scientific literature, but in today's video, I'm just going to share with you the approach that I personally take. Much like the training and programming guidelines that will be set out in flexibly periodized autoregulatory systems, you can then determine what does and doesn't work for you and adjust accordingly. So what I'm actually going to do is flip the screen around here so you can see what's going on my screen, and we're going to kind of break down an example scientific research paper together so you can really kind of get a visual of this and get the most out of the discussion. All right, so scientific research papers are typically broken up into a few different sections. The most common ones are the abstract, the introduction, methods, results, and discussion sections. Now, not all of these will be included in every paper you read, and some papers will actually even include additional sections. But nevertheless, these are the core five, so to speak, that you will most frequently run into. I'm just going to briefly summarize the function of each of these sections, and then I'll kind of delve into how I tend to navigate them. Just for a little background before I do this is a paper on wave loading, and I found it on a website called PubMed, which I will delve into in greater detail in terms of what exactly the website is and how to use it. For now, the topic and content of the paper are not really that important, so you can just kind of ignore that. I just have this up here as a visual for you to follow along and see what I'm talking about as I kind of go through each section and discuss how I navigate a paper. So, as you can see here, the first section is the abstract. And the abstract, well, it can actually take usually takes one of two forms. The one that you see here is essentially a paragraph or so summary of the most important points of the study. Now that typically includes a sentence or two of introduction and or explanation of why the study was carried out, a few key details on the design of the study, the most important or relevant results generated by the study, as well as a sort of a condensed version of the author's interpretation of those results. When you search for research articles on a site like PubMed, again, which I will delve into later on in this video, the abstract is typically the first thing that pops up. It will actually look like this. So you can see this is just the abstract here. It's not the full text. And that is for two reasons. One is because the abstract gives the reader an idea of what the study was about, and so it really serves to inform as to whether the study is relevant to what the reader is interested in, whether it's worth reading the rest of the paper at all. And then the second reason has to do with issues of whether you actually have access to the full text of the paper, and that's something, it's another thing that I'll go into in much greater detail later on. The other form of abstract looks something like this, and the difference, as you can see, is it actually it's not one continuous paragraph. It actually includes each of the sections, a number of which I already mentioned, that are included in the study, but rather than give you all of the content from each section, it just gives you a brief blip, so to speak, from each section, just to, again, serve the main purpose of giving the most important points or information from the study so you can determine whether it's something that you want to read in full, and whether it's relevant to what you're interested in. So those are the two main forms of the abstract that you will see. Moving on from the abstract, the next section we can see here is the introduction. It is sometimes called, and this one is called the background. It's exactly the same thing. And essentially, as the title would suggest, this section is an introduction of the topic of the paper in question. And it typically provides background information on previous studies conducted on related topics or on the same topic. And it usually also paints a picture as to where the gaps in knowledge, so to speak, are that are going to be filled in by the study in question. So in other words, the authors want you to understand that while past studies might have found X and Y, Z still needs to be determined or elucidated, and so that's what their study is going to investigate and try to find out. So that's the introduction section. Moving on from there. Next one is the materials and methods section, sometimes just called the methods section. And this outlines really in great detail what exactly the researchers did for their study. So that typically includes a description of the characteristics of the subjects and how they were selected. You can see that here in the subjects section, or subsection I should say. It also includes the experimental design of the study. So that would be addressed in this one right here, experimental approach to the problem, as well as procedures, and then this goes into specifics, the training program that was used, and then it also often includes the statistical analyses that were carried out by the researchers on the data, on the raw data that is. And so I actually think the methods section is probably the most overlooked section of scientific research papers, and that's for reasons that I will discuss shortly. Next up is the results section, and this contains all of the data of interest generated during the study, which usually includes the raw data as well as the results of any statistical analyses or manipulations that the authors might have conducted. While the authors might comment sparingly on trends and relationships in this section, they typically don't go into depth on these things, and they also try to avoid discussing or proposing underlying mechanisms that might explain or drive the relationships and trends observed, because this is reserved for the last section. Well, not always the last section, but one of the last sections, and that's the discussion section right here. And this is essentially where the authors of the paper do give their interpretations of what the results of the study mean practically. So this includes proposing mechanisms that may explain or drive the trends and relationships observed in the data that was generated by the study. It includes putting their results into the context of the body of research as a whole, and that's really in order to see if their results agree or don't agree with the general consensus, if there is one, as well as why that may or may not be the case. The discussion section also tends to include the researchers offering practical applications and takeaways from the results. And usually they also acknowledge limitations to their study and what the potential implications of these limitations might be for the practical relevance of the results. And on occasion, the researchers will suggest future avenues of research that might be of interest to other researchers based on questions that their study either raised or failed to answer. So, as you can see, scientific research papers are typically written in the order that I just introduced these 5 main sections. And so a lot of people assume that we should probably just read it in that order. And if our goal is to objectively gather information from the study and avoid biases that might affect this objectivity, I would actually argue that they shouldn't be read in this order. I typically tackle research papers with a different approach, and I'll share that with you now, and you can kind of be the judge of whether it works for you or whether you might want to try something different. So the first commandment, so to speak, of reading scientific research has to be thou shalt not be an abstract scientist. And the term abstract scientist really refers to individuals who only read the abstract of a paper and then think that it provides enough information for them to fully understand what the study was about and what the researchers found. The reality of this, however, is that because the abstract is just a summary, by necessity it kind of leaves out a number of smaller details that are still going to be critically important to how you interpret the study results. It's really rare for an abstract to truly capture every important detail about a study. So I would really argue and highly recommend that you don't rely on the abstract to provide details or conclusions about the study. In my mind, the abstract is only really useful if you're browsing through studies and just need to find out if a particular study is relevant to what you're interested in. And once you've made that determination, I think it's kind of time to move on from the abstract. In fact, if I know that a paper is going to be relevant to my interests ahead of time, I actually won't even read the abstract because I don't want the condensed conclusions of the authors, as well as the lack of details on the study design to impact my own interpretations of the study's results. So, if our true starting point isn't going to be the abstract, then the next most logical assumption is probably going to be that it's going to be the introduction, because that's the next section in chronological order most commonly. And my take on that is that I would say that's probably, in most cases, okay. It's probably a good place to start. As I mentioned previously, the introduction provides background information on the topic being studied, which includes descriptions of related studies, and it typically also explains why the study in question is being conducted and what questions that it hopes to answer. So this is great if you're reading a paper on a topic that you're not really familiar with, or, as I'll discuss at length later, if you're looking for other related studies to add to your reading queue. And you can actually see here there are numbers scattered throughout the text of this introduction section here. If you hover the cursor over them, a citation pops up. And so you can see that there's a number of references throughout this section, and that's just the introduction section referencing past studies on related or the same topic, and that will become useful when you're looking for other research studies on a related topic, and again, I'll come back to that at a later date. I just wanted to highlight that briefly. If you don't, however, fall into either of these categories, and again, those categories are that you're not really informed on the topic or that you're looking for other studies to add to your reading queue, so if you don't fall into either of those categories, the introduction section becomes more or less dispensable. Personally, I probably read the introduction section of a paper about 85% of the time, maybe a little bit more than 85% of the time, because I tend to read papers from a number of different disciplines, many of which I'm not even remotely close to an expert in, and so I kind of need some background information before I start digging into the nuts and bolts of the study in question. It is important to note that the literature review in the introduction section, while usually meant to be comprehensive, can sometimes be limited. And despite the best intentions and efforts of the researchers, it can occasionally also be biased. And so thus, it might not paint a truly whole picture of the body of literature in general. Now, this doesn't render the introduction section useless, because it still provides valuable information in most cases, but it is something that should be taken into consideration when you're reading this section. So all in all, I think the introduction section is probably worth a read, but you certainly should keep a skeptic's eye in terms of the potential limitations of the scope of the literature review. The next section, scrolling down here, is the materials and methods section, or just the methods section. And I think this is where you really need to focus up and dive into the details. As I mentioned earlier, I just feel that it's the most overlooked section because most people just consider it to be the boring details, I guess, of how the study was set up and conducted. And what these people fail to understand is that these very details of the study design really determine what the limitations to the conclusions that you draw from the study will be. So the methods section, for example, lays out what variables are and are not being controlled. And as I mentioned in my last video, if potentially confounding variables aren't being controlled, then the certainty with which we can conclude that there's a relationship or not a relationship between the variables being manipulated or tested is cast into some degree of doubt. The methods section also explains how the variables of interest are being measured, and different measurements, or different types of measurements I should say, tend to have different benefits and limitations, and that's also going to impact how you interpret the results. So these are just a couple of examples of how the study design details that are laid out in the methods section can really profoundly impact how you interpret the results of a study. And hopefully this kind of highlights for you the importance of not taking the section lightly. For me, if the methods section isn't the first section that I go to when reading a research paper, then it's absolutely always the second, just because I really think it's that important for laying the groundwork with which you're going to draw your own conclusions about the results of a study, hopefully in an objective manner. So, once you have a solid understanding of the details of the design of the study, we are ready to move on to the results section right here. The first thing that I'll note about this section is that it's really imperative that you do not skip it and jump straight to the discussion section. The results section, assuming it's done appropriately by the authors, objectively presents the data generated by the study, and is hopefully free of subjective interpretation. And so because of this, reading this section allows you to really draw your own conclusions about the data without any biases. The discussion section, on the other hand, it contains the author's subjective interpretations and opinions on the data, which if you read those first before examining the actual data itself in the results section, could impact the way that you view and interpret the data in a way that really compromises your objectivity. So the discussion section should really thus serve as a means to compare your interpretations and opinions of the data following reading the results section to those of the authors in the discussion section to see where you might agree and or disagree, and why or why not that might be the case. It should not serve as a means to preemptively guide your interpretations and views of the data, again, as this kind of compromises your objectivity, which is not something that we want. So that pretty much covers the approach that I use to read a research paper, and that'll do it for part one of this segment on finding, reading, and analyzing scientific research. In the next section, I'm going to briefly cover three different things. One is finding relevant research papers in the first place. The second is different types of studies, and how that applies to flexibly periodized autoregulatory systems specifically. And then the third is a cursory overview of statistical analysis and how to kind of interpret that, at least on a very simple level, because that's a discussion that could be its own video. So that's it for part one. Take a look at part two to continue on with this discussion of finding, reading, and analyzing scientific research. Thanks.